Welcome to the Reciprocal Functions practice set. Please like this video if you find it helpful, subscribe to the channel for more math help, drop a comment, question below, and check out the many other videos and playlists on the channel. Without further ado, pause the video to work these problems on your own, and then come back to check your work. All right, so let's take a moment and go over these. So for the first five are asking you to state the transformations, and I'm sorry that got really crowded in there. So I'll try to clear that up. Hopefully that wasn't too much of a problem. So the first problem was f of x is equal to 1 over x plus 3, and then the minus 4 is on the outside. And what we want to remember from the lesson is like what makes the graphs go left and right and what makes them go up and down. And so our left-right shift is going to be in the denominator of the ratio. And so this one will go left 3 units, and then this one is our up down, and the minus 4 means the graph will go down 4. And that's really all you need to do to state the transformations, just left, right, up, down. We do have a couple of flips in here. You can go back to the video for more details on that if needed. Okay, second one. We have f of x is equal to, sorry about that one there, 1 over x minus 2 plus 5. And again, we have our left, right, and that is going to go to the right 2. And this is our up, down, and this is going to go up 5. So which number is doing which? Otherwise, this is exactly the same as other transformations that we've looked at in other families of functions. Number 3, f of x is equal to negative 1 over x plus 1 and then a minus 1. So the negative is going to flip it over. Now, I typically in my classes and in my videos will just simply say flip. You can express that other ways, though. The technical math word would be a reflection. This is a reflection over the x-axis, although these graphs have some symmetry to them that can make that a more interesting conversation for another time as well. But that will flip it over. Then we have a plus 1 in the denominator, so that's going to send this left 1, and then a minus 1 on the outside, which is going to send the graph down 1. So there we go. Next one. We've got, let's see. F of x is equal to 1 over x plus 2 plus 4. And once again, we have that plus 2, so that is going to send our graph left 2, and the plus 4 is going to send it up 4. And then last but not least, we have number 5, f of x is equal to negative 1 over x minus 3 minus 5. And we have a flip or reflection. Make sure you answer that however your teacher wants you to answer that question, the vocabulary and notation that your teacher is requiring. This is going to be right 3, and this will be down 5. Now, you'll notice that I didn't cover like all the transformations, so I did not do dilations in here, like whether you're stretching or compressing the graph. And that's mostly because it does get more difficult to graph it. It's not that it doesn't happen, but getting a visual on it is not as clear-cut as it is with something, say, like a parabola or an absolute value function. And so just that was like my call as like somebody teaching this, like what are the valuable things to know, and decided to focus on the translations and on the reflection, not necessarily on the dilations and the stretching and compressing. Now, one thing before we move on from this, that flip, that negative sign, because of the way fractions work, I'm going to come over here and just use this space over here. You could write like the fraction negative 1/2 like this, or like that didn't really make that look as different as I wanted. There we go. With the, or like that with the negative out in front. Either one of those is fine. It's the presence of the negative that does cause the reflection on it. And then again, for the sake of clarity, I am aware you could put the negative in the denominator as well. And then that gets into potentially like a flip over another axis. Like I don't think I want to go into that. Maybe I'll record a separate video where we can kind of talk about that aspect of the fractions. But if that tripped you up because the negative was in the numerator instead of out in front of the function, hopefully that answered that question or that concern for you. Okay, sketch without a graphing utility. So we're going to hand draw our coordinate planes, and I'll show you how I do these. I obviously did it in the video. Sometimes I record these out of order. I record the practice set before I record the lesson, and that is for processing and linking the videos together, which is what I did this time. I don't always do it that way. But the way I go about this is let's go find those asymptotes. So we know that this graph is going to go left 4 and it's going to go down 3. So what I'm going to do is sketch in my tick marks going left 4 and down 3. And I am going to put in those asymptotes because they are a feature of the graph. They are not part of the graph itself, but they are a feature of it. Like, where are the asymptotes for this function? And once I do that, I kind of think of it as sliding my coordinate plane. So instead of using my original axes to anchor my graph, I'm going to use my slid asymptotes. So we went left 4, down 3. And so instead of doing my graph on the original, I'm going to do them on the asymptotes. Some students do visually find this very, very challenging. Because it's hard to like kind of block out the other lines. And I've seen students kind of do this and then this down here, and they're like looking back at this set of axes instead of where the asymptotes are. So just be mindful of that. So I'm just going to go ahead and sketch that in. There we go. Okay, and if you like wanted to like erase those original axes, you could kind of see that it's the same graph, just in a different location. All right, next one. We've got this one is going to go right 5 and up 1. So I'm going to do the same thing. I'm going to draw my tick marks in 1, 2, 3, 4, 5, and then up 1, and then put in the asymptotes. So they are going to assist me. And I always appreciate when my students do this because sometimes these are not the neatest graphs. Sometimes the way that we draw them, we can get a little bit messy with drawing them and they can like look like they hook or curve or something. And but if you draw in the asymptotes, you're giving your teacher like that much more information about what you know and what the graph should look like. So even if your graph is a little bit messy, it might grab you an extra point or two. Okay, and so here we go. So we're going to use the asymptotes. So here's my upper right and my lower left, and I want to make sure that I am clearly going over that x-axis there. And I know that looks like it's kind of like bending back. And again, that's what I meant about sometimes these are just hard to do. It's hard to draw in things that look like they're doing the right thing at the asymptote. But having the asymptote there and then making sure that I am crossing over that x-axis so that, and if you're not sure, like, what is she talking about? Right here. Because if I draw it down here below the x-axis, then I leave it in question whether I understand if the asymptote really is at the y equals 1 instead of at y equals 0. All right, last one. We have a flip on this one. We are going to go right 1 and we are going to go up 4. So let's go ahead and draw our tick marks. So right 1 and up 1, 2, 3, 4. And as before, I'm going to go sketch in my asymptotes. So I'm going to be using those. Now, what does it mean for these to flip? Well, the parent function looks like this. It's in the upper right and the lower left. When we flip it, it ends up, this flips down into the lower right and this flips up into the upper left. And so we're basically going to be using different quadrants on this one. So I'm going to be using the upper left, and again, I want to make sure I cross that axis. I'm not leaving any question about where the asymptote is, and then we're going to be using the lower right. So that would be a good sketch. Do I want to build a bridge based off of a sketch that accurate? Absolutely not. Is it good enough to show that we know the key features, we know the shape of the parent graph, we know like where the asymptotes are, that we know what the asymptotes are, not just where they are, but what they are, how the graph behaves around them? Yes. Okay. And so we always want to keep in mind, what's the point? Like, why are we being asked to sketch this? And lastly, find the vertical asymptotes. Now, for this, I really want to demonstrate how I encourage my own students to do it. A lot of students will just say, x cannot be equal to 0. That's not the key takeaway. It's not that x can't be 0. I mean, that might be true. What is true is that your denominator cannot be equal to 0. Okay, it's the denominator. So in this case, x minus 4 is what can't be equal to 0, the whole denominator. And when we get into more complicated rational functions, that denominator might be like a quadratic. And so now we're going to kick over into some factoring. It'll be fun. And then I go ahead and I solve that. Now that actually gives me the domain. That x cannot be equal to 4. But what is at the 4 instead? The asymptote. So that is actually my domain, which I did not mention in the lesson. So we'll kind of put like a little asterisk by that. And I'm going to say here the vertical asymptote is at x equals 4. Why? Because that's where the break is. X can't be equal to 4. What's there instead? An asymptote over here. So we'll say the denominator cannot be equal to 0. So in this case, 2x plus 4 does not equal 0. Go ahead and solve that. So we subtract 1 from both sides. So 2x cannot be equal to negative 1. Divide both sides by 2. X cannot be equal to negative 1/2. That's the break in it. That's where you go from like this little piece over here to this piece over here. Okay, that break is happening right at x equals negative 2. So where is the vertical asymptote? The vertical asymptote is at x equals negative 1/2. And I don't know what just came out of my mouth a second ago. I think I said the number 2. I don't know. Negative 1/2. I don't know if I said 1/2. Like, I don't know. But that's where the vertical asymptote is. All right. So as always, just want to give that quick reminder. Give this video a thumbs up if you found it helpful. Subscribe to the channel for more math help. Drop a comment or a question in the comments below. And check out the other videos on the channel. So YouTube thinks this one is a great for you video coming from our channel. And I hope to see you in a future video.